Greetings and welcome from a parallel universe where this Mr. Waddy never made a mistake. Well, anyways, we're talking about factoring today, and you're still my internet friends in this universe, I believe. And I hope I'm not in the universe where all my students are my real-life enemies. That would be unfortunate. But either way, I will teach friend or foe mathematics. And today we're learning about factoring x squared plus bx plus c, specifically when c is negative. And here's like the book's explanation of it. It works. It makes sense. However, I like this little phrasing of mine that says, find the factors of c that subtract to b whenever you're factoring this and your c is negative and you have a positive one leading coefficient. Not add. No, that definitely might have happened in another universe, but not this one. So let's see. Factoring, let's do example 3. So it's much the same approach. So here's 21. I'm going to ignore the sign for now. I'm just going to find the factors of 21, which are 1 and 21. 2 doesn't work. 3 and 7. And which of these, based on my C term, subtract to be 4? So 1 and 21 have a difference of, 20, and 3 and 7 have a difference of 4. And I worry about the sign at the very end, and it'll save you half of your guessing and checking. So I'm going to have, in parentheses, my unfoiled version, or my factored version, will be an x with a 3 and an x with a 7. Well, let's find out. Let's analyze that, because our internet friends aren't quite ready for it yet. So these multiply to be a negative, so their signs are going to be different, and they add to be a positive, so the more influential of them must have been the positive one. In that case, this would be the 7. So it's a positive 7 and a minus 3, and that is what my friend Brandon had just said, right? So x minus 3 and x plus 7. So it's much the same process. I'm just picking my factors differently, right? I'm looking for the ones that subtract this time to be my B term. So let's do some more of these and get some more practice. It's gonna be great. Don't you worry, friends. All right, so here we go. I've got some monitoring progress questions here for us. Here's 6, 7, and 8. Wonderful, wonderful, wonderful. All right, so all of these happen to have negative C terms. So I'm going to find the factors of C that subtract to B. All right, so here we go. 15. Factors are 1 and 15. 2 does not work. 3 and 5. And let's see. Let me pick some cards here. Kayla, which of these subtract to be 2, if any? 5 and 3 have a difference of 2. I like it. So I'm going to ask Tyler to help me out with the signs once I get this set up. So I'm going to have an x with a 3 and an x with a 5. And so, Tyler, they multiply to be negative, so the signs are different. What do you think the signs are going to be so they add to be a positive 2? Plus minus or minus plus? They had to be a positive, so the more influential one must have been the positive one. So which? Yeah, and if I check that, right, that still would multiply to be negative 15 and add to be positive 2. Monitoring progress, question 6. It should be after example 3, I believe. So here we go. X minus 3 and x plus 5. I believe so, yeah. Should be. Yes. All right, here we go. Let's see. So Brandon, help me find the factors of 30. And give me a full list this time, too. 1 and 3? 1 and 3D, yes. And what else we got? Yeah. Yeah. Yeah, it does. Yeah. Okay, with an alley-oop. 3 and 10? Nope. 5 and 6. Okay, let's see. And Austin, can you help me take this problem the rest of the way? So I'm looking for the factors that subtract to be 13. So this would have a difference of 29. And so I'm going to pick these ones, right? Am I going to have two, X's in the parentheses this time, Austin? No, it's going to be a Y and a Y, right? A Y with a 2 and a Y with a 15. Austin, could you walk me through how am I going to pick the signs for this? Okay, so 15 minus 2 is 13. I like that reasoning, yeah. And those still would multiply to be the negative 30. I like it. I like it a lot. Cool. All right, let's see. Let's shuffle the cards again. Ooh, this one's got some V's in it. All right, let's see. Factors of 42. Oh, Brandon, you get the factor job again. All right. 1 and 42, I agree. I like it. Now watch this. 3 goes into 21 7 times, and 7 times 2 is 14. Or if you just know that 3 goes into 42 14 times. 4, no. Does 5 work? No. 6 works, I think, right? 6 in what? No. 6 and 7. All right. Whew. That is actually, yeah, it's 42 and 48. I always mix those up myself. So I'm going to have a V with something and a V with something. But how do I pick which factors I want, Austin? How am I going to pick them? I want the factors of 42 that do what now? All right, you're catching up. I want them to subtract to be what number? Where's my number? Yeah, there's an invisible 1 there, and it's negative. So let's see, 42 and 1. All right, he's saying 6 and 7. Here, I'm just writing down these differences. Yeah, I think so. So V with a 6, V with a 7. Wait, let Austin take it. Why do you say that? So the more influential one had to be negative. And their signs are different because they have to multiply to be a negative 42. I agree. All right, let's do one more problem regarding gardening, which, by the way, I've got some raised beds at the house I bought last year, and I ended up creating a spreadsheet, of course, representing every square foot in my garden. And yeah, and then I was actually able to find out how long it takes for each plant to reach maturity. And so I labeled each square foot with like tomato or spinach or corn and had a countdown based on when I planted it. And then the cell of that square foot would change color from red to bright green as by percentage it got closer to the day it would be ready to harvest. I love spreadsheets. But anyways, here we go. It says a farmer plants a rectangular pumpkin patch in the northeast corner of a square plot of land. The area of the pumpkin patch is 600 square meters. Oh my goodness. What is the area of the square plot of land? All right. So this dimension, wait a minute. It says, wait a minute. Oh, okay. So this entire length is S, right? So if this entire length across is S, this length is 30, what would this length be? Does anyone know? It's going to be 30 less than whatever S is. Okay, so if S was 50, then this would have been 20, right? If S was 60, then this would have been 30. If S was 100, then this would have been 70, right? I know that this distance plus 30 is equal to S, so therefore this is going to be S minus 30. You guys agree? All right, could someone help me out with this distance? The entire distance across is S. s minus 40. I think I agree. All right. I think I agree. So let's see. A farmer plants a rectangular pumpkin patch. Okay, so this is a rectangle, the pumpkins. I see those pumpkins. All right, the area of the pumpkin patch is 600. Okay, all right. So this is 600 right here. And how do I find the area of a rectangle? Length times width. And I happen to know their length and width. So it turns out the area is going to be s minus 40 times s minus 30. Ooh, this is a good problem right here. And that area is equal to 600. Now, if I wanted to solve this, we're going to get more into these on Monday. Well, if I wanted to solve this, I can't use the zero product property yet because these things don't multiply to be 0. Here, so watch what we do here. I'll walk us through this because this is completely new territory. We've never planted these pumpkins before. I'm going to FOIL this out. Let's see. So we'll pull that in. So s times s is s squared. S times 30 is negative 30s. This is going to pull together a whole bunch of our different skills. Let's see how we can do it. Let's see. Distributing negative 40 times s is negative 40s. And distributing negative 40 times negative 30 is going to be positive 1, 2, 0, 0, I believe. Yeah, 4 times 3 is 12, and 0. I've got some negatives in there, so that'll balance it out. All right, let's combine like terms. So s squared is what I get. How many s's? How many? Agreed. And then plus 1200 equals 600. So now I've multiplied this out. I want to set this equal to 0 because when it's equal to 0, I'll be able to factor it and use the zero product property. So see if you can follow along with me here. To get this set equal to 0, what do I have to do with this 600? Minus it from both sides. Okay. All right. So I'm doing a lot of work here. Let's see what we get. So I'm going to get s squared minus 70s plus 600 equals 0. And now what I'm going to try to do is the following. I want to find the factors. I'm going to try to factor this, okay? So then I can use, right, I'll have two things that multiply to be 0, and I'll be able to solve, is what I'm trying to do. Okay? You with me? So that's where I'm trying to go. In order to factor this, I'm going to need the factors of 600 that add to be 70. Oh dear. Okay, let's try. 1 and 600. 2 and 300. 3 and 200. Let's see, 4 must work. 4 and 150. I'll try to help us on this. 5 and 120. Nope. Let's see, 6 goes into 120 30 times. Nope, 20 times. And 20 times 5 is 100. So 6 and 100. Okay, still moving. 7. I'm thinking not. Does 8 work? 8 and 50? Or 8 and 75? Yeah, I think 8 and 75 is the combo there. All right, 9, I don't believe works, because there's only one multiple of 3 there. 10, does 10 work? That should be an easier one. How many times does 10 go into 600? 60. All right. Yikes. Here we go, guys. 11 doesn't work. 12 goes into 65 times, so that's 12 and 50. Yikes. Because 5 times 10 was 50. All right. 13. 14 doesn't work because 7 didn't. Does 15 work? Yeah, 15 went into 150 10 times, so 15 and 40. Already? Yikes. Let's see. Did they give it to us? I gave it to you accidentally? Oh, maybe not. Oh, that's an if. That's a what if, though. So that's going to be a different answer. Let's see. 16, I don't believe will work. 17, 18. 20 works? Okay. Yeah, 20 and 30. I think we've gotten most of it. All right. And I see the one that we need. So I'm looking for the factors of C that add to be 70. So this would add to be 601. This would add to be 302. Right, 154, 125, 106. Notice actually later on towards my list, what is this set of numbers doing? They're getting less, right? So the smaller my number, the further down in my list I want, and the closer together my factors become. All right? Let's see, this would have been 83, and this would have been 70. Ding, 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 ding. So, the factored form of this, I'm going to scroll down for space. I'm going to have an S with a 10 and an S with a 60. Equals 0, still here. They multiply to be positive. So their signs are the same, but they also add to be negative. Minus, minus. Okay. Whew. Lots of work there factoring that. I think you guys agree. Now that I've got two things that multiply to be 0, what can I do with them? No? You guys remember? If two things multiply to be 0, one of them has to be 0. So either S minus 10 equals 0 or S minus 60 equals 0. Does that make sense? Do you remember doing that from a couple days ago? We're going to do some more of that on Monday. And you don't have a problem like this on homework tonight, so don't fret. Let's add 10 to both sides. Here, I get S equals 10. And let's add 60 to both sides here. And I get S equals 60. Don't pack up yet, friends. We're not done. Now, what did they ask us? They said, what is the area of the entire square plot of land? Now, I got two solutions. S is 10 or S is 60. Could S equals 10 work? If this is 10 by 10, then how could this be 30? How could a length shorter than 10 be 30? 10 doesn't make sense. Or think about it this. If I plug in 10 here, 10 minus 40, this is a negative 30-foot wide or meter wide pumpkin patch. It doesn't work. So this solution won't work in terms of the geometry, but it does work in terms of the algebra. And the area of the pumpkin patch is going to be 60 times 60. All right? And the area of the pumpkin patch will be 3,600 square, or not the pumpkin patch, the entire field, meters squared. All right, thanks for watching, Internet friends. Have a great day.